We're going to finish up Chapter 2 by looking at split stems, which is commonly misunderstood, and the example in the book is a little confusing, but so we'll try to straighten that out. And we're also going to look at some misuses of graphs. So first, the split stems. So we have an image here from page 37 in Pearson showing a stem and leaf plot, and they purposely let the spots in here that have nothing in them show, so you can see the total construction, how it might look. This saves no space at all over showing the data. It actually makes it longer. Notice the stems on the left. Some of those stems are things like 0, 1, 2, 3. Others are numbers like 10, 11, 12. So you see the stem is actually 2 digits long if you wanted to take a 0 to the left of 0, a 0 to the left of 1, a 0 to the left of 2. So that's one thing to notice. You can also shorten this by truncating it. Now the detail on this is given on page 38 in Pearson. So if you look at the top one, it's 0 followed by 057. So they've truncated a digit. And the easiest one to see is probably 340. You see the bottom of the top example, they have the 3 and the 4. They've truncated that 0. Truncation is not the same as rounding. For truncation, you simply chop off something. You don't round it up or down. So I've given an example that has nothing to do with this plot. It's pretty clear, I hope. So if we truncate the decimal portion of 13.7, we have an answer of 13. Now if you notice the top stem and leaf plot, it's kind of nice that it's compact, but you lose some of the detail. So something gained and something lost here. The one on the bottom actually shows pretty nice distribution. If you flipped it on its side, you'll see it kind of looks like a hill. It looks like it's the metric distribution. You can see it tails off toward the 0 end and it tails off toward the end with the 3, 4. That wasn't so apparent in the top one. Notice we only have a stem of 1 digit this time. I think that's where it gets confusing. You get from a stem of 2 digits to a stem of 1 digit. So what I'm going to do is to do a version with you where it's not that way. And you can read this in detail. Do it as slow or as fast as you want. So this is the data set I'd like you to work with. 11, 12, 14, 15, 16, 16, and 18. I'd like you to make a simple stem and leaf plot. So stop the video, stop whatever you're doing, take out paper, ruler, pencil, make it. Now see if you can split it. The problem we have with the current data set is all the numbers actually go between 11 and 18. So you could think of it between like 10 and 20. That's a really short range of data. That's when we need to split the stem. So we're going to split this stem. A lot of times we'll split it between something like 10 to 14 will be 1/2 of the stem, and 15 and 19 will be the other half. Some people may have split that to be between 11 and 15 and 16 and 20. So I think it's, you can't put that 20 in, so you'd have to go like 16 to 19, and I think your stems in that case are uneven size. 10 to 15 is actually 6 digits. 16 to 19 is 5 digits. Now I'd like you to not only do those two, but to then take something that has 3 digits in it and do the same thing. So you notice everything starts with 1, 1 in this data set. And I worked this out with a student over the weekend, so that it seemed to work pretty well for that person, and hopefully it'll work for you. So do the same thing as before, having a 1-digit stem, and do that, and then splitting it. And now do it 2 digits on the left for the stem. So the 2 digits would be 11. To the right of that would be the 1, the 2, the 4, the 5, the 6, the 6, and the 8. And see what you get. So take some time to make those. We're going to look at misuses of graphs. I'm directing you to look at page 80 here. I believe all of these are on page 80. So redraw this, but show the percentages below 30% also. And then redraw this pie chart, which they've shown at an angle, but do it from above as you do a normal pie chart. And I want you to discuss all of these with other students or someone around you if you don't happen to be at school when you're doing it. This is a time plot. You notice on the right-hand side, they didn't truncate it, but they kind of shortened it, and they made that part from 2006 to 2013 a steep line. What would happen if we didn't do that? What would happen if we put in 2007, 2008, 2009, 2010, 2011, 2012, and then the 2013 and drew a line between 2006 and 2013? How would it look? So do those. See how this effect is changed when you change how you show the graph. And a short word on percentages. So percentages without the numbers given can be very misleading. So always look for the numbers they base these percentages on. Take time to read this, but I'm going to end the video now.